Okay, our last problem here is find the sine of theta if tangent of theta equals 13 over 9. Remember that the tangent is the opposite length over the adjacent length. So we'll draw a picture. We'll put theta in the lower left-hand corner just to stay consistent. We'll draw an arrow going to the opposite side, which is 13. The adjacent side is 9. And the hypotenuse we will call r. So we know that 9 squared plus 13 squared is equal to r squared. So 81 plus 169 is equal to r squared. 169 plus 81, that's a 0. Carry the 1, that's 15. Carry the 1, that's 250. So 250 equals r squared. Now, when I square root both sides, because 250 is not a perfect square, I square root both sides, I'm going to have to break down the square root of 250. So I'm going to come over here. I'm going to show my work right up here. 250. 2 goes into 250 125 times. 5 goes into 125 times 25 times. 5 goes into 25 5 times. We're looking for pairs, so we have a pair of 5s with 5 times 2 left over. So 5 on the outside with 5 times 2, which is 10 on the inside. Now, I'm using a different color here where I have not been using different colors for the problem because we have a radical, and I just don't want that to get lost. I'll go back to using red here because we need to find the sine of theta, and the sine of theta is the opposite side, which is 13, over the hypotenuse, which is 5 times the square root of 10. So we have 13 over 5 times the square root of 10. But remember, we can't have a radical in the denominator, so we are going to have to rationalize that. I'm going to rationalize that by multiplying the denominator by the square root of 10 and the numerator by the square root of 10. That's really multiplying this existing fraction by a factor of 1. Anything over itself is 1. So this fraction times 1 is not going to change the value, but we are going to change what it looks like. And it is going to look like 13 times the square root of 10 in the numerator, and then 5 times the square root of 10 times the square root of 10 is just 10. And 5 times 10 is 50, so the sine of theta is equal to 13 times the square root of 10 over 50. Now, before I box this answer, 13 and 50 are both on the outside of a radical, so I need to make sure it doesn't reduce. It indeed does not reduce. So our final answer is the sine of theta equals 13 times the square root of 10 over 50.